This video is going to be all about our anamnestic response, which is called our secondary response. So the process that we just went through was all part of our primary immune response, which is what happens when we first are exposed to a new pathogen. Okay, so we have to activate all those cells and then make plasma cells. B cells, activated B cells also differentiate into memory cells. And so we're generating all of this. So it takes a hot minute. But once we've been exposed to that pathogen and we've generated antibodies and memory cells, those memory cells make it so that the next time that we encounter a pathogen, we have a much quicker response time. And so this is our secondary immune response. So this is what the other part of your diagram, your antibody-mediated response diagram, is. I mentioned that activated B cells differentiate into different types of cells. So one being plasma cells and the other are memory B cells. And so these memory B cells kind of hang out in the body and they wait for you to encounter that pathogen again. And when a memory B cell comes into contact with that antigen again down the road, that memory B cell automatically starts dividing into plasma cells. Okay, there's no activating virgin T cells, which has to find the right virgin B cell. All of that activation stuff stops, or it doesn't have to happen again because it's already happened. So again, once that memory B cell comes into contact with the pathogen, it automatically goes and divides into plasma cells, which starts releasing all of those antibodies so that the pathogen can be eliminated before we reach a diseased state. Okay, so it eliminates the pathogen during the infection stage so that we never actually get sick and hit the diseased state. So this is just a nice visual that kind of shows the difference in time for the primary response, which is on the left, versus the secondary response, which is on the right. So I'm not going to read every part of this to you, but notice with our primary response, we've got these naive B cells. Okay, and there's also those naive T cells that have to be activated. And so it takes about a week for that naive B cell to become activated and to create some kind of short-lived plasma cells that are then going to go and release all those antibodies. Okay, and so then it can take up to about 30 days to have those long-lived plasma cells in the bone marrow and to generate those memory cells. So it takes a while, right? About a week at least for those plasma cells to be made so that we can start releasing lots of antibody. But look at what happens once you encounter that same antigen again in the future. Now it's our secondary response, and we've got that memory B cell. And as soon as it comes into contact with that antigen, it's going to start differentiating, and we're going to have lots of plasma cells and lots of antibody within just a couple of days. Okay, and so you can see how the amount of antibody is going to peak at different points if it's a primary infection versus a secondary infection, and kind of how that graph looks during the primary response versus the secondary response. Okay, same overall shape, but it peaks a lot sooner in our secondary response. We make a lot more antibodies a lot faster. So there is a video here. We're not going to watch it together, but I posted this on the Blackboard site as well. So let's review now the types of immunity. There are two types of immunity based on where the antibodies come from. So active immunity is when you are actively generating your own antibodies, or if we're thinking in the healthcare profession, the patient has generated their own antibodies. Okay, that is active immunity. With passive immunity, you or the patient or whomever is given pre-made antibodies. So some other human or animal has made those antibodies and you are just giving them. Okay, so you're acquiring it in a passive manner. So again, with active immunity, you are actively acquiring and building your own antibodies. With passive immunity, you're getting them from somebody else. They're already made. So let's take a deeper dive into active immunity. So again, this is where you've made your own antibodies. Okay, so the immune system has produced antibodies in response to the presence of an antigen. Well, you can naturally acquire, okay, so it's naturally acquired active immunity when the person's exposed to a live pathogen, right? You get sick and then you get better, okay? And then because we have memory cells, when we encounter that pathogen again, right, we are protected. But we don't want to encounter things like measles or tetanus and things like that. Right? We don't want to have to build our own against antibodies against those, because we could die in the amount of time it takes to produce antibodies. So that's where things like vaccines come into play. This is artificially acquired active immunity, because we aren't actually just encountering the pathogen on our own out in nature. We are given we're given an inactive pathogen or a toxin or whatever the case may be, but we simulate a response, right, by injecting the antigen into our body. Okay, so that is artificially acquired because we did not naturally interact with this pathogen out in nature. But regardless, if we naturally interact with the pathogen or if it's artificial, our own immune system is producing the antibodies. So these are still classified as active immunity. When we talk about passive immunity, which again is when the immunity comes from somebody receiving pre-produced antibodies. So this can happen naturally. Okay, so remember we talked about IgGs that can cross the placenta and IgA, which is produced in secretions like breast milk. So infants, or the fetus or an infant, is naturally acquiring these pre-made antibodies, right? The mom made the antibodies and is giving them to the infant. So the infant is passively acquiring these antibodies, okay, in a natural fashion. And then artificially acquired is going to be when immunization is going to occur by the injection of antibodies that are not produced by the recipient's cells. Okay, so for instance, say you're playing outside, maybe a young kid is playing outside, steps on a rusty nail. Maybe they've been vaccinated, maybe they haven't. If it's an adult, maybe they haven't received their booster. So what is going to happen is they are going to give you TIG, which is pre-made antitoxins, and they will inject it with you. That way you have this immediate source of antibodies that are going after that toxin. Okay, and so again, TIG is just pre-made antibodies. They're going to inject into you, so you're acquiring them artificially to help go round up that toxin. Okay, and a lot of times they'll also give you the booster then, or vaccinate the kid depending on what the situation may be. But these are pre-made antibodies given in response to essentially a dire need for them. All right. We're going to go ahead and stop this video here, and we'll make the next video all about cell-mediated immune response. So you're going to want to have that diagram handy.